So in the last video about graphing linear equations, we started with an equation that looked similar to this in the form y equals mx plus b. And we said that m was the slope and that b was the y-intercept, okay? And so we went ahead and graphed that equation. Now I want to talk about a similar type of equation, but the slope is negative. Okay, so here you have the y-intercept is b, and it's 4, and the slope is equal to, just like before, the coefficient of x. So in this case, the coefficient is negative 1/3. Okay, so now we would normally plot the 4 on the y-axis. It's a positive 4, my mistake, so it's right here. And then we would need to use the slope to go over and up or down. So over, left or right, and then up or down. But let's look at how that works with a negative slope. The slope, negative 1/3, I'm purposely trying to write this negative in the middle, right next to the fraction line, so that you can see that in order for this to be negative 1/3, you have to either have the numerator be negative or you have to have the denominator be negative, okay? In either of these cases, that's why I have the equal sign, in either of these cases, it's still negative 1/3. It's not both, because if you had both negative 1, and both the 3 and the 1 negative, then that would not simplify to 1/3 because the negatives would cross out and you'd have positive 1/3. I mean, it wouldn't simplify to negative 1/3, which is what our slope is. So this is not correct. So in this case, you can have either the rise. Remember, this is correlating to the rise over the run. Okay. So in this case, what this tells you is that you can either pick this fraction where you go up 1 on the y-axis and then negative 3 on the x-axis, or you use this fraction and go down 1 on the x-axis, the rise being negative, and then forward 3 on the y-axis, on the x-axis. So watch this. Here's our point, and I'm going to pick this particular version of the slope, and I'm going to go from this point, starting at this point, I'm going to go down 1 and over 3. That's, negative on the y-axis and positive on the x-axis, and there's my second point. And I'm now going to draw the line connecting those dots. And like before, I'm going to extend beyond the points and put arrows to remember that this line goes on forever. So that's how you do a negative slope. You can write this fraction either way, but whichever one you pick, you use that for the rise and the run using the negatives as appropriate to go up or down or left or right. One other quick point, just to remind yourself about how slopes work. When you say a slope is negative or positive, a way to think about it is that you're a person standing on the line and you are looking in the positive x direction, okay? If that slope in the positive x direction is downward from you, then that is a negative slope, okay? And if the slope is upward, then this is a positive slope, okay? So if you graph something and then notice just check what the sign is on the slope and see whether it's going up or down from where you would be standing in that example I gave you, then you can kind of just tell if it's been drawn correctly. Do you really have a negative slope or have you drawn a positive slope or vice versa? So that's how you graph with negative slopes using slope-intercept form.